Hey, you're Steve Tech. I'm Steve, and I'm going to give you a little bit of lifter tech today. Now, I'm not going to go over every single nickel and dime little thing because there's a lot of information out there on lifters, but some of the higher end stuff there isn't a lot of. And then I'll just give you some other special tech that I don't normally see people talking about and what's affecting things. So, first thing we're going to talk about is we'll just go right to the standard old hydraulic lifter. Alright, so we'll start out with hydraulics. Now this is a General Motors hydraulic lifter. No big deal. This is actually for an LS, so it has lifter trays that come down here and grab it and keep it located. One little thing that people don't really understand is that when the lifter is going up and down and rolling on the wheel right here, it really doesn't use the lifter tray. There's nothing there. In fact, the tie bar, in fact, any of these things that keep the lifter from turning is only to keep the lifter turning when it's on the base circle of the camshaft, because the lifter could actually turn slightly, and as it came up on the camshaft, boom, spring pressure would make the thing go perfectly flat and go up and down. It really, believe it or not, doesn't hardly need any type of location, very light, very minimal, if the valve train is correct. It just isn't going to do anything. But because it will go up and down, and it will go up and down straight without the tie bar. The tie bar is only there to keep it that little bit of potential of twisting when it's on the base circle of the camshaft. But anyways, that's just a little side note. So how the hydraulic roller lift works, we'll just go over that quickly. Not going to spend a lot of time, and then talk about a limited traffic lifter. So if you look right here, this is your hydraulic roller lifter. Okay, now inside of here, there's a clip that's holding this, and there's your push rod cup right there. Okay, push rod cup, and that's your push rod cup. And then there's this plunger that's underneath it, and then there's a spring that's holding it up. That's why you can push on the cup when there's no oil in it, and it feels like a little spring. All right, so your normal lifter is going to have, normal hydraulic lifter has about 120 to 150 thousandths of up and down movement. When the lifter fills up with oil, depending on the clearances and how good a lifter it is, that push rod cup will self-center, and then the hydraulic effect of it will keep it from decreasing too fast. So it has to squish all that oil out of the lifter. Well, it can't really do that very fast, so hence it doesn't collapse. That bucket, that plunger, and the cup don't go down because it's got to force that oil out first. That's why you'll see if you just have the valve covers off, you roll your motor over and let one valve be all the way open. Leave it there for a little while, and that will gradually bleed all of the oil out of that lifter, and that lifter will then just be having the spring pressure in it because it's empty of lifter, or empty of oil. Okay, so not a big deal, and that's why a lot of times, especially in race hydraulics, you start them up and they're just noisy for like just very quickly. Perfectly normal, don't worry about it. Now, a limited travel lifter means that it'll usually only go down about 30 to 60 thousandths will go down, instead of that 120 to 150. And so what that's doing is, just in case it was bleeding down, or we wanted to run a bunch more spring pressure on it, and we'll kind of talk about that here. Spring pressure on it, if it does collapse, it doesn't collapse all the way down and cause this really weird valve loss or valve lift loss. So both of them preload pretty much the same. The limited travel lifters, which are a better, higher RPM deal because we can run more spring pressure on them. Usually preloads is somewhere in the neighborhood of 30 thousandths. Regular hydraulic lifter, the full standard depth, will preload about 60 thousandths, right around there. All right, so now one thing that you'll see too is that actually lifters pumping up or having any problem like that actually is a problem with too light a spring pressure. Because what happens is, if we look at this lifter and it's got a little bit of preload and it's riding in the middle of its stroke or up at the top part of its stroke. If it loses control of the valve, so our push rod is right here, all right? So this is our push rod. If it loses control of the valve, this push rod cup tends to go up. So all of a sudden, this push rod cup is up here, and when the valve comes back down to close, it's going to be held open. That's what lifter pump up is. So you're too weak of valve spring pressure allows the valve train to float, allows this push rod cup to go up, and then when the push rod comes back down, it's got oil behind it, can't squirt it all the way out fast enough, holds the valve open. That's what lifter pump up is. All right. So there's a bunch of information out there you can find on hydraulics, pretty common stuff. You are going to find that in really good race hydraulics are pretty much converting everything over to a limited travel. Just because the only reason we're even using a limited travel hydraulic or any type of hydraulic is purely noise. That's it. Just noise. People don't want to have any kind of clatter, light clatter, especially in cars with good exhaust. Okay. Now, one thing you can do, top secret, is you can run a solid lifter. Now, obviously, a solid lifter like this is no hydraulics in it. There's no cup. It's just plain out solid. Everything is solid. All right. You can run a solid lifter on a hydraulic roller camshaft. Yes, you can. I do it. Do it fairly often. You can do it. What you need to do is typically we'll lash the valve at 5 thousandths cold. You can do it hot. Sometimes you have to be careful with that, but normally I'll lash them up at 5 thousandths cold, put a solid roller lifter on a hydraulic roller camshaft, and then we kind of split the difference and throw some valve spring pressure in it, but not a whole lot. Not your normal, 700, 800 pounds over the nose and big solid cams, but we could be down there in that 500, 600. But with the solid roller lifter on a hydraulic roller camshaft, we have this really smooth camshaft with all the benefits of having a solid roller lifter and the higher RPM capabilities. Okay, we'll probably talk a little bit about that more when I go over camshaft load profiles, but it is doable and it actually is a pretty good thing and works really well. And when you're lashed at 5 thousandths cold, they're very quiet too. So, and you can actually play with those numbers, and sometimes you can get it even quieter. You just want to make sure that it's not being hung open when the motor's cold. Remember, motor's cold, everything shrinks. The block and head actually shrinks. Well, it shrinks a little bit more because of the mass than what the valve train shrinks. So sometimes it would hold the valve open when it's stone cold. Valves are open when it's cold. Thing doesn't start. No compression. Okay. So let's go to the different style of lifters. Wanted to talk to you about that. So we had that hydraulic, pretty easy deal. Has a tray that comes down here, keeps it all located nice. No big deal. They'll also do those in a tie bar style. So when you hear tie bar, this is a tie bar style lifter. This is all pretty simple, elementary stuff. They'll put tie bars on a retrofit hydraulic rollers. No big deal for earlier big block Chevrolets or small block Chevrolets, anything other than LS basically. Then let's go to the next style, which is pretty common, is a Keyway style. But before I go to the Keyway style, let's actually talk about, there's a dog bone style, which actually has a plate that goes over a lifter. Instead of the tray, it actually has what looks like a little dog bone, like a little figure 8 that goes right here and captures the lifter. And remember, all that tie bar stuff, tie bars, keyways, slots, radiuses, that's all just to keep the lifter from turning when it's on the base circle of the camshaft. So there's dog bone style. Don't see those much anymore. They've bolted down with a plate. Sometimes they look like a little spade, 2 little clips like this, but don't really see those much anymore. The other way people really like to do it, and I don't mind doing it, but there is one problem that has always bugged me about it, is a Keyway style lifter. So this is a Keyway style lifter. Hence, Keyway key. Now this Keyway lifter eliminates the need for the tie bar because that Keyway is riding right in there and keeping the lifter located. Typically we'll do this. This is a 937 lifter. There's 1062. There's even a 1131 or 1130 lifter, something like that. We'll talk about bigger lifters here in just a minute. But this is the different style of lifter. So this Keyway lifter isn't bad. You do need to have a bushing for it, so that's pretty common. Higher end motors will have these, like a Jessel or a Crower makes, or I'm sorry, Crower does. Isky makes Keyway style lifters also. Diamond-like coatings on them. I mean, they're really good stuff. No problem with that. But what I've never liked about them is that all the oil needs to go around this band. So imagine you have 16 of these things, bing, 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 and oil has to come around this band, this really light little skinny band, goes through the oil galley hole, which is fine, and then has to go around another band, and then another band, another band, another band, another band. And you can't take these back out. So now you have this block that's wrapped around that lifter just like this. How are you going to clean out behind that oil galley? It's really hard. If you eat up a bunch of material, you eat up parts, have a lot of fine particles, it is impossible to get all the debris out from behind this because it's all encapsulated. So that's just one of my little common complaints about this. It's not the end of the world, but it can be kind of a bugger. Now, and installing these is not the easiest thing in the world. It's not the worst, but it's not the easiest thing. A more common lifter, if bushing, would just be standard bushing like this, and it's just bushing the hole, but the oil galley still goes all the way through it. I personally like that because since we do so much more endurance type engines, I like to have lots of oil going to the valve train. Oil to the valve train cools the valve train, lubricates the valve train, keeps parts alive. That's what we need to do. So I also like to have, in my SMX stuff, I'll do them with Keyway bushings if people want. If they want that, that's fine. But I'd like to have it set up with tie bars. I like the tie bars because you could have a lifter value failure, could have some kind of problem. You grab this tie bar, yank it out. This lifter sticks in a lifter bushing. Where you grabbing onto that to take it out? Where do you grab that to take it out? It is a mother to get these lifters out if you ever do have a problem. On the side of the road in a cornfield like what we do in drag week, that's a big deal to get that thing out. It sucks. So anyways, I like to use the tie bar lifters versus the Keyway lifters just because of those two reasons right there. The hydraulics, kind of talked about that and what you can do with a solid lifter on a hydraulic camshaft. Now we'll talk about materials of what we're doing. So if you look right here, I kind of drew this up. This is your normal bearing. So if you're ever hearing about bearingless or a bushed lifter, what they're talking about is this is normally your axle right here, right through the center. I'll show you the lifter. So that's your axle right there. That's your wheel. This is your wheel. And in between there is a little Torrington bearing, just these little needle bearings. If you've ever broken a lifter, and breaking lifters is fairly common, especially if they don't have enough valve spring on them, or have too much valve spring on them, or don't have the right push rod. We talked about push rods, deflection, how the push rod sends the lifter up, or sends the valve into a loft area. A lot of little problems there, but all that stuff adds up. And you break that wheel in this lifter, and it sends those little itty bitty bearings throughout the entire motor and just peckers everything all up. There's little pecker marks on your connecting rods, bottoms of your pistons, cylinder bores, everything, because all that material, those bearings, just flies everywhere. The bearings just plain out are strong enough. So what the current trend is, and what we've really helped us out in all of our drag week stuff all the way back in 2012, 2013, 2013 is when I really swapped everything all over to everything being bearingless. No bearings in lifters, no bearings in rocker arms, no needle bearings in anything. Want everything to be bushed. So instead of that bearing that's right there, they just put a solid bronze bushing. Now the bushings are pretty tricky. There's a lot of different material and there's a lot of science behind all that. I'm not really interested in it. I just know that this thing works and lasts better with that bushed lifter. All right, and we can do that now on hydraulics, so the hydraulics become better, but definitely do it on this in the solids, because as the load profiles get more aggressive, they really get harder on that bearing, and that's why those bearings will sometimes fail. All right, if you go back to our lashing valves video, and I tell you, you're only just checking to see if anything's broke. Could care less if this thing was a 1,000ths or 2,000ths difference and you're checking valve lash, who cares? This thing is 10 or 20,000ths different, you better go find out what's broke. And a lot of times it's going to be lifter wheel is going away. But if this lifter wheel breaks or has any problems with the bushing in there, it just sends a few bigger pieces in the pan. Not nearly as big a deal as sending a whole shrapnel full of needle bearings in there. So really like to have all the bush lifters. Now you do have to have lots of oil to that lifter. It needs to have good oil pressure, good volume to keep everything cool and well lubricated, which in my personal opinion is the other reason why I'm not a big fan of the Keyway lifter, because these really are minimal oil that can go around the band, come up through the hole, then it's got to go to the next lifter, go around the band. So I mean, by the time it gets all the way down the end, a lot of times we'll have, if we use these, we'll need to put oil feed lines in the front, and then somewhere near about 3/4 of the way into the back of the lifter valleys, so we get oil back there, because not enough oil ends up flowing all the way through. The back lifters always have problems if you don't have these oil lines over there. But never have the problem on a Keyway style with this type of big groove. See how much bigger that groove is in the oil galley. Oil galley is full diameter. This is getting a lot of oil through it. Much better for the that ultimate duration stuff. Now let's also talk just real quickly about the lifter wheel size. Common Chevrolet lifter size is going to be 842. Common Ford size is 875. That's stock from the factory. So as we continue to go bigger diameter lifters, the reason for bigger diameter is could care less about this diameter. That really is not the deal. What the deal is we're trying to get a bigger wheel. Now this bigger wheel makes, I'll talk to you about the lifter, why the lifter likes it first. We'll talk about why the camshaft likes it later. The bigger wheel, we can put a bigger axle in it. It's stronger, more durable. We can put a bigger bearing in it. It's stronger and more durable. Point blank. That's all the lifter cares about. This thing's going up and down, rolling on this wheel. We just want it to live the best that it can. So on all my SMX stuff, we're at a 904 or 937 tie bar style lifter. I'll do them in a Keyway 1062, 1130 if you want to go that big. I mean, there's a lot of stuff there. Makes really big wheels, which is better, softer on camshaft profile. I'll talk about that later. But that is the nuts and bolts of what we're looking at for lifters. So think about that Keyway style. If you ever hear that, that's what it's talking about. 937 Jessel or Keyway lifter, 1062, whatever you're going to come up with, 1 inch. A lot of different, little different combinations that the lifter and camshaft people will come up with. But that's what we do here. That's why we're doing that. I hope that is some good information for you. And we're going to be doing, I think, rocker arms next. So we'll talk about that part of the valve train and then finally go to the camshaft. So I'm Steve Morris, Steve Tech. Have a great day.